All right, thank you for joining us today. And in this video, we are going to talk about related rate, right? Related rate using these questions, right? So, with related rate, there are some things that you need to, know. One thing that you need to know is with related rate, mostly we use the implicit differentiation, right? So they will give you the function, but we are going to differentiate the function with different variable or maybe one of the variable, right? So with this one like this, since the function is with time or measured in time, we are going to differentiate with respect to what? T. So that is the idea. So with related rate, there are some things that I want to show you. So when we are reading related rate questions, you can hear some word rate, right? And mostly rate, if we need to go with time, then I represent rate as d over the t, right? You can hear something like increasing. So when you hear increasing, it is plus, right? So increasing, or let's say up. Up, you can see up in when the question is given in the form of maybe a ladder and then a wall, right? So that one is positive. And then decreasing is like down, which is minus, right? Then what other thing that we can also talk about? Okay, so maybe definitely as we are doing it, we will know things that we need to also learn from the function. Right, right. Good. So let's just put this one down up here. So as we are doing related rate, you read the function, you read the question, you extract the information down, and then you try to what? Make use of every information given to you. Right. So from the question, we have cost and price. So cost is equal to 24x plus 3000. Then we have the price to be equal to minus 0.16x plus 120. And then, we want to try to find, so, okay, we have that one. So now, where cost, revenue, and this are all functions measured in months, and then they are currently increasing production at the rate. So some of the words that we need to increasing rate, right? So I said rate goes with this. So now we know that we have rate, which is d over the t, because we are going with time. Increasing, it means that the figure here is going to be positive. But the question is, what should we multiply by this? Like, what should we multiply by the d? So the d is going with the production. So the production is like the quantity that we are going to make. So our quantity is the x, right? So it means that here they are currently increasing production at the rate of this is going to giving us like something like dy over what? The x. Did I say dy over the x? The x over the t, which is equal to 15. So you see how I was able to get the information there. Increasing, it means that this one is going to be positive. Rate d over the t. But I need to have a function here that I'm going to put it here. So that is what I need to go and look for. So I saw that, okay, the function that they are talking about here is the production. The production in this question is the quantity, which is the x that we are going to produce. So this is from the preamble. Now let's look at the question. What is the question asking us? At what rate, so rate d over the t, is revenue. So we know d over the t, which is going with revenue changing. So it means that here the question is asking us to look for the r over the t. So that's what we need now. So when we are reading the question, you try to extract the information. Now, when production is 150. So remember we said production is the quantity, which we know that quantity we represent it by x. So x is equal to 150. So this is what we extracted from the question A, but this is what we extracted from the information here. So now anytime you are done extracting the function and you don't have function given to you, I mean, right now we need to find dr over dt. So now what are we going to look for? We look for what is here, which is the revenue that they are talking about. So for us to know something like dr over dt, then we need to know the revenue function, because without the revenue function, we cannot find dr over dt. So that's the next thing that we need to go up to. So what is the revenue function? What's the formula for finding revenue? So we know that revenue is the quantity times price, or price times quantity. All of them is the same. But we see that the revenue here is in terms of x. So we need to change P, which is the price. So this is going to be x times, what is the price? Price was given to us here, which is what is here. So minus 0.16x plus 120, and this is going to give us minus 0.16 x squared plus 120x. So this is our R, which is the revenue. So this can help us to find for the R over what? The T. Good. So let me push this information up here small so that I can make use of here. So now let's differentiate this function. But remember, we are differentiating the function with respect to what? T. So I'm going to have d over dt on the left, which is r, which is equal to d over dt on the right, which is going to be d over dt minus 0.16 x squared plus 120x. So when I differentiate r, so let me put this one in parentheses. When I differentiate r with respect to t, I'll get the r over the t, which is what we are looking for. Then now I differentiate this with respect to t. So don't forget here we are going with respect to t. So see what I'm going to do. When I factor my 16 out, 0.16 out, now I need to differentiate x squared. So when you differentiate x squared, don't think about it here. What is here? When I differentiate x squared, what is the normal derivative for differentiating x squared? We differentiate x squared, we get 2x. But here, we are differentiating with respect to t. So we need to multiply this one by the x over the t. Yes, we need to multiply it by the x over the t. If we are differentiating this one with respect to x, then when I multiply it by the x over the x, it will be 1. So since we are not differentiating with respect to x, we need to multiply it by this quantity, which this quantity is given to us here, the x over the t. Plus, when I differentiate 120x, I factor the 120 out. So let me close the parenthesis here. Then differentiate x. When I differentiate x, what am I going to get? 1. But I need to multiply it by d over dx over dt. So this one will be dx over dt. So this is what I'm going to get. Let me simplify it, and I get minus 0.32x dx over dt plus 120 dx over dt. Minus 0.32 times, what is x? X is, we have x, okay, good. X is 150 here. X is 150 plus, no, not plus, the x over the y is 15, which was given to here, plus 120 times 15 again. So let me try and compute this using calculator, okay? So what are we going to get from here? 0.32 times 150 times 15 is going to give us 720. So it will be negative 720 plus 120 times 15, 120 times 15, which is going to give us 1800. Then when I do the subtraction, I'm going to have this. So this will be the result for the first question that we were trying to solve. All right. So now the next question here is, at what rate? So as soon as I see rate, since here is with respect to time, okay, so I'm thinking of something like d over dt, but I need to multiply it by something. What am I going to multiply it by? Profit changing. So here we are looking for the p divided by the t if we are assuming that profit is equal to p. So this is what we are looking for. So you see that this one, we are looking for the r over the t, and that's what we have here. Good. So that's what we are going to get. Now production is 360, right? So now we need to look for the profit function so that now we can look for the p over the t. So now what is profit? Profit is equal to revenue minus cost. Yes. So what did we get for revenue? When we were solving for revenue, this is what we had. So minus 0.16x squared plus 120x minus what is C? C is the cost. Cost is given here, which is this. So we are going to have 24x plus 3000. So this is going to give us minus 0.16x squared plus 120x minus 24x minus 3000. And this is going to give us minus 0.16x squared plus 96x, I think so, yes, minus 3000. So now this is the profit function. So now we need to differentiate that. Right, so now let me pick, let me try and then push the final results up there so we can have some space. So we had this one to be equal to this, so that I can clean here and use the space there. Good. So now that we have this, now that we have this function here, we can now compute what we are looking for. So now let's try and compute the p over the t. So p is equal to, so I take the derivative of the one on the left here, I take the derivative of the one on the right. So this will be d over dt of minus 0.16x squared plus 96x minus 3000. So this one should be 3000. So d, when I differentiate p, I'm going to get the p over the t. So we just learn how to differentiate this here using the power rule. So this one is going to give us minus 0.16 out 2x, but we need to multiply this one by dx over the t plus 96. When I differentiate x with respect to t, I get dx over the t. Then when I differentiate a constant, I'll get 0. So this is going to give us minus 0.32 x dx over the t plus 96 dx over the t. So when we do substitution, what are we going to get? We know x, the x given to us is 360. And what is the x over the t? the x over the t was given to us in the preamble, what is 15. So when we do substitution, we are going to have minus 0.32 times x is 360 times 15 plus 96 times 15. So we are going to have, let's do the calculation. I left my minus. So if we are doing the calculation, 0.32 times 360 times 15 is going to give us 1728 plus, this one should be minus, then 96 times 15 is going to give us 1440. And when I do the subtraction, I'll have negative 288. So this is what I'm going to get for the profit. So you see that if there is a change in the profit, we are going to get deficit. Actually, it is going to decline, right? So that's what we are going to get for A and B. Let's look at 2. Let's look at 2. So this is the P over the T, what we were looking for. Let's look at 2. So 2, quantity is X, price is P, and then price demand equation is given to us right here. Good. So let's read A and extract information. If the price is decreasing, so when it is decreasing, what do we have? Minus. Okay. So when price is decreasing at a rate, with the rate to, what do we have? D over the T. This. So now let's extract information that we have here. It is decreasing. We know that the rate is going to be D over the T. But what is the rate going with respect to? The rate is going with price. So dP over the T is equal to that. And then there is decreasing here, what will affect the 2.5. So we are going to have minus 2.5. So we have extracted one information. At what rate? So at what rate again? D over the T is the quantity demanded changing. So what's the quantity demanded? The quantity demanded is X. So actually we are looking for dx over the T. At what rate is the quantity demand change? So dx over the T. So that's what we are looking for. Good. When the price is $40 and demand is the same as the quantity. So, and then X is equal to 20. So we need this, but fortunate for us, we don't need to find for quantity because this equation here, which is the price demand equation, is having X. So all we need to do is we need to differentiate this function and then with respect to T, and then we are going, right? So I'm going to differentiate the left with respect to T, then differentiate the right also with respect to T. One in front. Good. So when I differentiate 2x squared, what am I going to get? So 2 out, differentiate x squared, I'm going to get 2x, but don't forget to multiply by the x over what? The T. Is that right? Plus, so let me close the bracket here, plus 15 out. Now I'm going to differentiate this. These are two functions because x is the quantity, P is the price. So we have two functions here. So here we need to use the idea of what? Product rule. So first, I maintain the x and differentiate P with respect to T, which is going to give us the P over the T plus, then I maintain P and differentiate x with respect to T, which is going to give us the x over the T. So if you don't know, you can use the product rule like what we just learned. A is equal to x, B is equal to P, A prime will be equal to the x over the T because we are differentiating with respect to T. B prime will be equal to the P over the T. So now this multiply this, which is giving us this here, plus this multiply this, also giving us this. Don't forget I factored the constant out. So now after constant multiply through. So don't forget, with related rate, we go with the implicit differentiation. Now when I'm differentiating 10p, 10 is constant. Then when I differentiate, I factor it that when I differentiate p, I'm going to get the p over the t. When I differentiate a constant, now I get 0. Good. So if I want to try and do some simplification here, I'm going to have something like this. 4x dx over dt plus, when I multiply the 15, I have 15x dp over dt plus 15p dx over dt plus 10 dp over dt is equal to 0. What are we looking for? We are looking for the x over the t, but we know the p over the t. So we know x, we know p. So let's do substitution. X is 20. The x over the t, we don't know. That's what we are looking for. So 4 times x is 20. We don't know the x over the t. That's what we are looking for. Plus 15. This is x. X is 20. What is the p over the t? That is negative 2.5 plus 15 times p is 40. We don't know the x over the t, right? So let me shift this one here small. Plus 10, the p over the t is minus 2.5, which is equal to 0. So let's try and simplify. This is going to give us 80 dx over the t plus 15 times 20 times 2.5. What are you going to get? 15 times 20 times 2.5. We are going to have 750, which is minus 750, plus 15 times 40. We are going to have 600 dx over dt. Then 2.5 times 10 is going to give us 25. So it's going to be minus 25, which is equal to 0. So we have this and this. So we are going to add this one to this. So we are going to have 660 dx over dt. And then we are going to add this to this, which is going to give us minus 775 is equal to 0. So actually we are going to have something like this. I'll move this one to the left, or I'll add and add here. So I'm going to have 680 dx over dt to be equal to 275, no, 725. Then I'll divide this one by 680, divide this one by 680. So the x over the t will be equal to 725 divided by 680. So this, you can simplify, but you can also leave it in this form. So that's what you are going to get for the x over the t. So 725 divided by 680. That is A. Now let's look at the B. Let's look at the B. What is B? Let's look at B. Now with B, if the quantity demanded is increasing, don't forget, with quantity demanded, that is the X. So here, increasing rate. So I have something like D over the T. What's the rate going with respect to? The rate is going with what? Demand. And we are saying that demand is X. So this is the X over the T, which is equal to, now this is increasing. This is not like decreasing that we are going to have negative. So this one will be positive, which is 4. At what rate is price changing? So rate, D over the T going with price. So we are looking for the P with respect to the T. So this is what we are looking for. And then demand, what is x is equal to 10. So the same preamble that we are going to use, you see that um, this one was the same preamble for A and B. So definitely we need to differentiate this with respect to t and this with respect to t, which we have it right here. But let's look at something. We have the t, the x over the t here. We have x here. We are looking for the p over the t. But do we have p? No. We cannot use the p that we use here because this p was inside A, not in the preamble. Like for example, we use the t for A and B because the x over the t was in the preamble. So this one, it means that for us to use this equation, which is the same as doing differentiating, we are going to get the same thing. We need to look for p first. How do we get p? Plug in x is equal to 10 inside this equation and let's find p. So 2 times 10 squared plus 15 times 10 p plus 10p is equal to 13,200. So 10 squared is 100. 100 times 2 will be 200. Then this one will be 150p plus 10p, which is equal to 13,200. So when I add this, I'm going to have 160p, which is equal to 13,200 minus 200. Because when I subtract 200 here, subtract 200 here. So 160p is equal to 1300. Is it 1300 or? Yeah, 1300. No, 13,000. Yes. So now what will be p? I divide this one by 160, divide this one by 160. So let's see what you are going to get for p. So 13,000 divided by 160 is 81.25. So this is our new p, 81.25. So I can clean up the solution here. And then now, since we are looking for the p over the t, we plug in values. So now 4 times, what is x? 10. So I'm using the same equation here. Then the x over the t is 4 plus 15 times x is 10. The p over the t, which we are looking for, plus 15 times p is 51.5. And then the x over the t is equal to 4 plus 10. Then we are looking for the p over the t, which is equal to 0. So this is what we are going to get. Equal to 0. So 4 times 4 is 8. 8 times 10 will be 80. Okay, so we are going to have 80 plus 150 the p over the t plus 15 times 81.25. Oh, this one's supposed to be 25 times 4 is going to give us 4875 plus 10 dp over dt. So we are going to add this and that. So this is going to give us 160 dp over dt, and then also add this and that. So when I add plus 80, I'm going to have plus 4955 is equal to 0. I'll subtract minus 4955 here, subtract 5944 here, 4955 on the other side. So we are going to have something like this. Let me shift this one. 160 dp over dt to be equal to minus 4955. Divide this one by 160. Divide this one by 160. So we are going to have the p over the t to be equal to. So this divided by 160 is going to give us 30.6 no 969. So this is what you are going to get for the p over the t. Now let's look at the last question here, and then the fourth question. You can just do them and put them inside, put your final results inside the comment section, right? So you try to solve these equations, right? Good. So maybe you are solving for x. So I'll give you clue here. You can factor 6x out, right? And then you just do from there. Let's do last one here. Now, anytime we are dealing with a question which goes with a letter and then a wall, what you need to think about is Pythagoras theory, right? So two things that you need to know is anytime you want to form the Pythagoras theory, which is going with right angle triangle, we need to have one known, two unknowns. One known, two unknowns on the right angle triangle. So as soon as I draw my right angle triangle, one of the sides should be known. The other two sides shouldn't be known, so that I can just give them variable like x and y. So when I read the question, if 17-foot ladder, so this is my ladder here, this is my wall. So let me just name them. This is ladder, this is my wall, right? So that I can rewrite or redraw them again and use them. So as soon as I see that the ladder is 17 and I put 17 here, one is known, which is 17. The other two shouldn't be known. So I'll just replace them by, let's say this one will be x or y and this one will be x. So that I can form the Pythagoras theory. Because anytime I need to form the Pythagoras theory, one should be known, two should be unknown whenever I'm dealing with ladder and what? A wall. So this one will help me to form the Pythagoras theory. So the adjacent squared plus the opposite squared plus is equal to the hypotenuse squared. So I'm going to have x squared plus y squared is equal to 17. So 17 squared. So this helps me to set up an equation where I can differentiate. Now I go ahead to read the rest of the question. So it starts to slide down the wall at 2 feet per second. So what we are trying to say is this is the image that we have, but the ladder which is against the wall try to slide down. So if we have this start to slide down, and when it slides down, you see that there will be small changes. So there is a change here, there is also a change here, right? And you see that this change here is going down here. And as I said here, anytime you're talking about down, it should be negative, right? So it starts sliding down. So there is a change. And if there is a change, there is a rate. So it means that that place we are going to have something like d over this one we are going with respect to t, but which one is it going with respect to? This one is going with respect to y, because we are on this side on the wall. We are saying that on the wall is y. So this one will be dy over dt, and this is equal to minus 2, which is right here. So down to minus, right? So this is what we are going to get. Now then, how fast is the bottom of the ladder moving away from the wall? So how fast is this guy moving away from the wall, right? So that is what we are going to look for. So actually we are looking for dx over dt, because the x is at the down. We want to look at how fast it's moving. So that's what we are looking for. Then the question is also saying that when the ladder is 8 feet away from the wall. So when the ladder is 8 feet away from the wall, we are talking about what is here? What is x, right? So x is equal to 8. So now we have a lot of information here, which will help us to, do what we want to do. So what we need to do is now we need to pick this function that we formed by using the Pythagoras theorem. We differentiate it with respect to t. So differentiate the left with respect to t, differentiate the right with respect to t. 17 squared. So when I differentiate x squared, I'm going to have 2x dx over dt. Don't forget, when I differentiate y squared, I'm going to have 2y dy over dt. And when I differentiate 17 squared, I'm going to get 0. So now we need the x over the t. Okay, so we need this. Do we have x? Yes, we have x. But do we have y? No. So how do you get y? We plug in x here and get y. So let's go and look for y. So we have x squared, which is 8. So we are going to have 8 squared plus y squared is equal to 17 squared. I subtract minus 8 squared here, minus 8 squared here. So I'm going to have y squared is equal to 17 squared minus 8 squared. So what will be y squared? What is 17 squared minus y squared? Let's see what we are going to get. So 17 times 17 is like 289 minus, this will be 64. So minus 64 of 64, what are we going to get? So this one is going to be 225. And then what root of 225? I think 15, right? Yes. So here it implies that y is equal to be 15. So y is 15. Y is 15. So that's what we are going to get. Am I lying? No, not lying. Yes. So y is going to be 15. So let's do the substitution. 2 times 8. We are looking for the x over the t plus 2 times y. Y is 15. And we know dy over the x, which is minus 2, which is equal to 0. So this one will be 16 the x over the t, which is equal to, which is minus 4 times 15 should be minus 60, I think. Let me confirm from my calculator. 4 times 15 is 60. Okay, that's true. I'm very smart. X is equal to 16, which is equal to 60, right? Then I will divide 2 by 16. Divide 2 by 16. Don't ask me what is 60 divided by 16. I won't tell you. I'll use my calculator to see. So 60 divided by 16. Oh, I was smart. I had this right. I said 3.75 in my head, which is right. All right, so this will be the dy, the x over the t, the change in x, right? The letter away from the wall. So this is what you are going to get at the end of the solution. So do the question 4 and place your final results in the comment section. See you in the next video.